At 12:01 a.m. on Black Friday 2023, Shopify processed 61,000 orders in a single minute. That's $4.2 million gone before you finish reading this sentence. Most e-commerce platforms collapse at 5x normal load. Shopify ran at 30x and never blinked. The question is, how? Think of it like a theme park on its busiest day. The magic isn't the rides, it's the queue. Let's put the scale in perspective. $9.3 billion in 24 hours, 61,000 orders per minute at peak, 99.99% uptime maintained throughout. That last number is the real flex. Anyone can handle volume if they're allowed to go down. Staying up under that load, that's the engineering challenge. Here's the problem every e-commerce engineer faces. Normal day, 1,000 users per minute buy sneakers. Black Friday drop. 500,000 users hit buy within 90 seconds. That's a 500x instantaneous spike. Your database has 5,000 connection slots. 500,000 users just knocked. Every one of them gets rejected. They all retry. It gets worse. Without proper architecture, 3 catastrophic things happen simultaneously. First, thundering herd. Everyone retries at once, making the overload worse. Second, inventory goes negative. 200 users buy the last sneaker at the same millisecond. Third, duplicate orders. Your slow connection times out, you click buy again, you get charged twice. 3 disasters. 1 spike. Disney doesn't let 50,000 people run straight to Space Mountain at once. They use FastPass, a virtual queue. You get a ticket with a time slot. You're admitted in controlled batches. The ride never gets overwhelmed. The experience stays great. Shopify built the exact same system for Black Friday traffic. They call it the queue. And it runs at the CDN edge, before a single request touches their servers. Here's what nobody tells you. The queue doesn't run on Shopify's servers. It runs on Fastly's CDN edge. That means 499,500 of your 500,000 simultaneous users are served a waiting room page without a single request touching Shopify's application layer. The database connection pool never even knows the spike happened. The park gate is miles away from the rides. When the request rate to a product URL exceeds 5,000 per second, queue mode activates automatically. Each visitor gets assigned JWT, a cryptographic ticket with their queue position and timestamp. A background process releases 500 tokens per second, matching actual checkout capacity. Users see their estimated wait time, refreshed every 10 seconds. Backend sees a flat 500 requests per second, not 500,000. The queue gets users in at a controlled rate. Great. But now 500 users per second are all trying to buy the same limited sneaker. There are 100 pairs left. All 500 read inventory equals 100. All 500 proceed to payment. All 500 complete checkout. Inventory is now negative 400. You just shipped 400 orders you can't fulfill. The queue saved your servers. The race condition just wrecked your business. Shopify solves this with a 2-phase inventory reservation. At the moment a user adds to cart, Redis atomically decrements the inventory counter. Not reads then writes, decrements. Single operation, atomic. If the result is 0 or below, Redis reverts instantly and returns sold out. The whole thing completes in under 1 millisecond. MySQL never sees the contention. Here's the actual pattern Shopify uses. A Lua script executes atomically inside Redis. No other command can interrupt it. Get the quantity. If it's 0, return -1 immediately. Otherwise, decrement and set a 10-minute expiry on the reservation. 1 round trip, no locks, no race condition. This single script prevents overselling across 1 million concurrent buyers. At first it feels backwards. Why not just lock the MySQL row? MySQL can do row-level locks. Here's why it breaks at scale. Under 500,000 concurrent requests, MySQL lock contention serializes every single inventory check. They queue up, wait times compound. Your checkout API response time goes from 50 milliseconds to 30 seconds. Redis runs single-threaded but processes 1 million operations per second with sub-millisecond latency. No locks needed. The reservation has a 10-minute TTL. Pay within 10 minutes. Inventory confirms in MySQL, and the Redis reservation clears. Abandon your cart, TTL fires automatically. Redis increments back, the unit becomes available again. No cleanup job needed. No orphaned reservations. The system heals itself. But there's still one more failure mode we haven't talked about yet. You're on a slow airport Wi-Fi. You click place order. 30 seconds pass. Nothing. Did it work? You click again. Now you have 2 payment attempts, possibly 2 orders, and a support ticket that ruins your holiday weekend. Shopify handles over 1 million of these duplicate scenarios every single Black Friday. The fix is a concept called Idempotency, and it's one of the most interview-ready ideas in back-end engineering. When your checkout page loads, Shopify generates a UUID, a unique token tied to your cart. Every place order request includes this token. Before calling the payment processor, Shopify checks, have I seen this token before? If yes, return the existing result. Don't charge again. The idempotency key is checked in Redis in under 1 millisecond. The second click is safe. The third click is safe. They all return the same order. Let's talk databases. A single MySQL server handles roughly 100,000 queries per second and 5,000 connections. At 61,000 orders per minute, that's 1,017 orders per second. Each order triggers 50 plus queries. That's 50,000 queries per second minimum, just for orders. Product page reads are 100 times more than order writes. One MySQL is already dead. Shopify runs hundreds of them. Here's how. Shopify shards MySQL horizontally using Vitess, a tool originally built by YouTube, open-sourced in 2012. The sharding key is shop ID. Every product, order, customer, and inventory record for a merchant lives on the same shard. Your application connects to a Vitess proxy called Gate with normal MySQL queries. Vitess silently routes them to the right shard. You never change your application code. Here's the elegant part. If a merchant goes viral, say they go from 100 orders per day to 10,000 overnight, their shard gets hot. Vitess can split that shard onto a dedicated server with zero downtime. The merchant gets their own database without changing a single line of code. Each shard also has 3 copies, one primary for writes, 2 replicas for reads, 3 times the read throughput automatically. Here's a number that reframes everything. On Black Friday, 80% of Shopify storefront traffic is served entirely from Fastly's CDN edge. 0 requests to Shopify's origin. Product pages are cached for 10 seconds, short enough to keep pricing accurate, long enough that Fastly serves 500,000 requests per second, while Shopify's servers see only 50,000. That 10-second TTL is one of the most carefully chosen numbers in their entire architecture. Caching product pages for 10 seconds is fine, unless a price changes mid-sale. Shopify solves this with surrogate keys. Every cached page carries a header, surrogate key, product 12345. When a merchant updates a price, Shopify fires one API call to Fastly, purge everything tagged product 2345, globally, in under 150 milliseconds. Every edge node across the planet serves the new price within seconds. No stale data. In 2019, Shopify ran a single global monolith. One bad database migration didn't affect one merchant. It affected every one of their 1 million merchants simultaneously. A routine schema change on a hot table triggered a full table lock. Checkout was degraded globally for 18 minutes. One change. Every merchant. The lesson was brutal. Shared infrastructure means shared failure. That incident directly caused Shopify's pod architecture. Shopify's answer to 2019 was pod architecture. Instead of one global system, they carved their infrastructure into isolated self-contained pods. Each pod owns a slice of merchants, its own application servers, its own MySQL shards, its own Redis cluster. A bad deploy in Pod 7 affects Pod 7's merchants only, not everyone else. The theme park analogy again. If one ride breaks, the rest of the park stays open. Amazon's Prime Day 2023 sold 375 million items in 48 hours, comparable load. But Amazon's approach to spikes differs in one key way. They use predictive auto-scaling. ML models trained on years of historical traffic pre-warm EC2 instances 30 minutes before expected spikes. They don't wait for an alarm to trigger. By the time the alarm fires, 60 seconds of requests are already failing. Prevention beats reaction. Here's the part that never makes the press release. Black Friday didn't go smoothly because of luck. It went smoothly because of 6 weeks of preparation. Shopify runs synthetic load tests at 150% of projected peak before the actual day. Every pod tested independently. Every slow database query found and indexed. Redis pre-warmed with the full product catalog. The theme park rehearsed with a full crowd before opening day. Let's zoom out and see it all at once. User hits buy. Fastly Edge serves from cache or issues queue token. Admitted user reaches Shopify app on GKE, Google Kubernetes Engine. App checks Redis for idempotency key. Reserves inventory atomically in Redis. Routes database writes through Vitess to the correct MySQL shard. Calls Stripe for payment. Confirms inventory in MySQL. Every step has a fallback. Every failure is isolated. In your next system design interview, say exactly this. For flash sale traffic, I'd implement 3 layers. At the edge, a metered admission queue to prevent thundering herd. In the cache layer, Redis atomic decrements for inventory reservation with a TTL-based release. At the application layer, idempotency keys on every order to prevent duplicate charges. Each layer handles a different failure mode. That's senior-level thinking. The part every tutorial skips. These systems fail gracefully by design. Redis goes down, fall back to database-level locking. Slower, but correct. Fastly has an outage. Origin servers absorb the traffic with rate limiting in place. A pod has a bad deploy. 999,000 merchants stay unaffected. The genius of Shopify's architecture isn't any single technology. It's that every component assumes the others will fail. Let's close the loop on the numbers. 80% CDN cache hit rate means Shopify's origin handles 50,000 requests per second instead of 500,000. The queue meters 500 users per second into checkout. Database connection pools stay under 20% utilization. Redis processes inventory reservations in under 1 millisecond. Pod architecture means a failure affects less than 0.1% of merchants. Every number maps to a deliberate architectural choice. Shopify's Black Friday architecture is really 6 interlocking ideas. Virtual queue for admission control. Vitess for horizontal database scale. Redis for sub-millisecond inventory reservation. Idempotency keys for safe retries. Fastly CDN for 80% traffic offload. Pod isolation for blast radius control. Remove any one of these and the other 5 can't compensate. The system works because every layer respects the limits of the layer below it. Every time a concert drops tickets, an app launches a flash sale, or a product goes viral, these same patterns apply. The thundering herd problem is universal. The inventory race condition is universal. The duplicate order risk is universal. You're going to design systems that face these exact problems. The difference between your best day and your worst outage is whether you built the queue before the flood arrived. Shopify processed $9.3 billion because they built the gate before the crowd arrived. A theme park that lets 500,000 people rush Space Mountain simultaneously isn't brave, it's broken. In your next interview, you now know what Shopify knows. If this clicked, subscribe. Tomorrow we're breaking down how Discord serves 19 million concurrent users on one database.